Um, Hello everyone. My name is Viet. Actually, people call me Viet when I'm in the United States, but just refer to me as Viet or Dũng for simplicity, I guess. So today I'll talk about the tutorials for the robotics topics. The motivation is how do we control the robots? In this case, robot arm. Um, how do we control it? Using normal conversation or message passing paradigm, and also using LLM language model to control the robot arm, I guess. So yeah, let's head right in. Okay. So so first of all, we have to have motivations, right? So nowadays, frontier works in robotics excels in implementing robots behavior and planning, right? Like for example, like creating autonomous robots that can actively explore the environment. For example, like planet exploration, and autonomous driving car, something like that. And then there are robots that can acquire knowledge and learn skills continuously. Then you ultimately achieve the envisioned in cognitive and development robotics, I guess. And then next is robots can learn continuously by interactions, right? So basically, the fundamental of all these applications is how do we control the robots effectively, and how do we learn to control the robots. So this is like the very first steps toward how you would work with the robots and further improve it or enhance it by implementing robot learning. Here is the actual robots that we are going to be using in simulations or in this tutorial. This robot is called PX100. It is developed by Tran Robotics or Interbotix. So the motivations here, as I mentioned, is how to control a robot and integrating LLM to robotics action planning. So the goal here is to learn how we do it using ROS2. So yeah, we have to learn the ROS2 theory, and then how do we control this robot arm per se using ROS2, and then we are going to do some small integration of LLM into the robots. So first of all, this is a little bit of the background. So if you look onto the let's see. So if you look onto this figure, this is on the left here is the generative process, and on the right is generative model. So basically, a generative process is whatever the environment is. For example, the robot's arm interact with this phone, for example. It's pick and place the phones, right? And then the generative process is what the environment represents in the robot's point of view. So it can be, it can contain a phones or whatever the color of the phones or the shape of the phones, something like that. And then it states, for example, the position of the phone in the 3D world. And um, and then it will serve as the observations um, to the robot arm, right? So the generative model here is the actual robot's brain, right? So it will try to learn how to plan the actions so that to interact with the observations or interact with the environments that's continuously produce the observation O. So that's basically the model that we are heading toward. So we have the robots, it's going to be here, the brain is going to be inside the robot or outside the robot. So in this tutorial, we are going to have this brain inside the laptop, and then that laptop will send the signals to the robot's arm, for example, to control the joint states. So all of this happens under the message passing paradigm, where the laptop here is the robot brain, it's pass the controlling message to the robots, and then the robots actually listen to the laptop command, and then it will do the actions, joint control actions, based on the commands passed from the laptop or the brain. Right? So next is the robots. The robots will have the hardware that is controlled by the brain, and it receive the it published the robotic states or observations that it receives from the environments or the generative process. And then the laptop here, which is the brain, will continuously listen to those robot states. So until this slides, do you guys have any question at all?
Any protocol for between the laptop and the robot?
Yeah, so that is the point of this tutorial. So we will use ROS or ROS2 as a protocol for the laptop and the robots for the communications between those. And ROS is standing for the Robot Operating System. So the reason why we use ROS is basically it's enhanced modular architecture, and has like message passing where nodes and communicates using a publish and subscribe or service call model. And then there's also hardware abstraction where it provides standard interfaces to sensors and actuators of the robots. And then there's different tools and like large community and ecosystem of software implemented in ROS and ROS2. So yeah, so that is the main motivation and the reason why we use ROS as a main communication channel and protocol between the laptop and the robots. So there's originally two ROS version. First of all is like ROS with no number is the original version. This one is like designed and implemented like a long time ago and doesn't not like really supports like modern robots anymore, I guess. Now we have ROS2. We added real-time support, security, and cross-platform capabilities, ease of use, and so on. So in this tutorial, I will be talking about ROS2 as a main communication channel between those. So yeah, first of all is the theory installations. So here I put all the links. You can also find out. But basically, if you click here, there's several things to note. So it's gonna be installed using different. So each ROS version has compatibilities with different version of Ubuntu. So I'd recommend using Ubuntu 22.04 and then have ROS2 Humble, which is a specific version that is designed for that Ubuntu versions. Yeah, so you can also check out the release in the to see like whatever the releases of ROS versions. There's like multiple versions that is compatible with a different version of Ubuntu. And then there is also Interbotix robot arm installations. So on top of the ROS interface, there's Interbotix. Also, it is like implementations of the control of the robot's arm implemented by the PX100 robots arm producer. That is like the software or the firmware of the robots that is implemented in ROS. So yeah, so next is the actual theory of ROS2 node or the ROS2. So everything's happens inside a node, a basic unit of computation in ROS2. So this is basically a program that performs a specific task within a robotic system. So in ROS2, a node is a process that uses the ROS2 API to communicate with other nodes. And each nodes you can see on the figure on the left, each nodes can have the ability to subscribe or publish, and then or it can be served as the service client or the service provider or server. So for example, some example of the nodes can be a camera driver nodes publishing image data. A navigation nodes subscribes to a sensor data provider and publish velocity commands to the robots, for example. And then another example should be a control node receives commands and interfaces with the robot actuators or motors or something like that. So yeah, so that's basically it. Yeah, so the next is a topic concept. So topic is it's like a communication channel. For example, in radio, you have like 60 hertz or 61 hertz or something like that. Then all those channels in ROS, it's called topic. And topic is not represented with a number of something hertz, but it's going to be represented in a string. So it is string. It's a string identifier, and it includes publisher and subscriber. It is like the main communication channels that brings on the interactions between the publishers and subscribers. So you can see a figure on the bottom left here. For example, node 1 serves as a publisher, published to a topic, and then this topic will host like some kind of message, and then it will broadcast all these informations to whichever nodes that subscribe to it. So imagine it is like a publisher that publisher is like a radio standpoints, something like that, and then publish to like several different topics, and then any nodes that subscribe to those topic can listen to the informations continuously. So let me actually have some demo. I'm gonna open the code.
Cần cho các bạn install ROS2.
Cái đấy nó hơi lâu. ROS2. Thế thì em sẽ so yeah, so if you go to like so you search on Google doing like ROS2 installations, ROS2 humble installations, and then click onto this very first link. Go to, if you're using Windows, then click onto Windows, and then I'm using Ubuntu, so I'm just gonna click into Ubuntu. So there's several different steps that is required to install ROS2. You can also follow this tutorials, but basically you have to actually set the locale first, and then installing all these software properties comments, and then finally install the ROS Humble desktop, and then do the environment setup. Yeah, so let's see if I can send the links to anyone.
How long does it take to install?
So it's normally installed in 15 minutes or 15 to 20 minutes. There's also another installation scripts from the provider of the robots, which also takes another 15 minutes. So I'm gonna just, for the sake of simplicity and time, I guess, I'm just gonna demonstrate the code actually in here. How does that sound?
I think it's okay. We could like for the demonstration.
Okay. Right. So there's several different let's see. Let me actually open this for. Okay. Let's open a new thing. I don't know. And can you actually see it? How do you? Okay, I guess. Okay, so now you can see it. So yeah. Where are we? Right. So we first of all have the topic list. There's several different comments that we can check topics. So the very basic comments is do like topic list. So there's so whenever there is a publisher that's published to a topic, it will shows up on here. So for example, if I do something like let's see. Okay, so there's one thing that I can run. There's one way that I can run a small program. So this is a turtle sim package where there's a turtle in front of the screen, and then we can control the turtle using ROS2. So basically, when we run this node per se, this is listening to a control signal or subscribing to a topic controlling the turtle topic. So after I run this turtle, I will check if there is any if there is any addition topic. So so ROS2 topic list. There's several different topics more, right? Let me increase this.
So this because you just start a new simulation.
Yeah, so this is imagine it is starting a node. So in here we have a node here. So this node actually is subscribing to a topic, right? So in this case, the turtle program is a separate node, and then it's trying to listen to a action command from the topic. Right. So you can see the post. There's several different way to control the turtle. There's a color sensor, command, velocity, and pulse. And then now I will run another node. It's called a run turtle sim teleop keys, where I will be able to control the turtle using different keyboards. So here I am pressing the upward arrow button, the right arrow buttons, and then upward arrow buttons, up arrows. So the reason why it's moving is when I click the arrow button, it will send a message in here. So it will send a message from the publisher to the topic, and then the turtle here is listening to this topic and listening to the actual commands of the keyboard that is sent by the publisher in the keyboard.
Now, how many publishers can you have?
Infinitely many. You can have as many publishers as you want, and at the same time you can send multiple messages to a topic. It's all happen in parallel. And then the subscriber will only, take in whatever the message is currently in there, in the topic.
I'm curious because the architecture about the brain and the actual robots, right?
Mm-hmm.
Yeah, earlier it seems more simple. So this one seems more complicated.
Right,
Is there any
right.
reason why they adopt this?
So I think it's for efficiency. It's for efficiency in a way that all of this is executed in parallel. So for example, if you can have like multiple multiple players that is controlling the total, and then one player's one machine is down, for example. There's also there's still another machine that is sending the message to the topic, I guess. Then it still keeps the control signal stable. I think that is one use case. I think there might be another use case as well. Yeah, so that's
Because
basically.
I'm really curious about why they have the nodes, and the nodes, they are not called subscriber, and then they're not called publishers. And then there's a concept of topic.
Yeah. This is a little bit more complicated. Yeah, I also have to agree. Yeah, but basically, I'd say.
So to do a robot control, you need to create a service, a subscriber node.
Oh yeah.
And then you also need to create a publisher node.
Mm-hmm.
And you also need to create the topics.
Yeah. Yeah. So normally, robots, for example, sending back real-time sensor data, it might not. Well, if you send back sensor data directly to the to the subscriber to the laptop, for example, it might process the data like sequentially, I guess. But in order for the parallelism and distributed computing purpose, I think it's just sending to a common gateway, which is known as topic, and then the laptop will just grab whatever the information is staying inside the topic. I think that might be one reason why, which is parallelism, that is making all these paradigm and structure more efficiently. Yeah. And then there's also service, but I'll talk about that later. Okay, we have topic already. Yeah, so there is also a trick that can be done using topic. So if you actually want to inspect the topic, what kind of data is it? What kind of like how do we also use it? And also do ROS2 topic info of your topic name, right? So let's do like ROS2 topic list to see what topics we are having, so we can see the current posts of the total, and then we can try to say ROS2 topic info and then that topic name. It will print out the type of the topic. Here is total sim message and post. It's a kind of message that we pass in to parse the actual data of the total when we are subscribing to that topic per se. And then if we want to actually seed the topics, want to stream of the topic, we can say ROS2 topic echo total one post. So it will have the actual numbers or the actual data that is currently inside that topic in real time. So if I move the total, for example, let's see. Can I move this out? Yeah, let's make another So ROS2 topic. Echo of the post. So here's the current information. Let me actually zoom it up. Okay, so when I control the turtle, you can see that it is currently changing in real time. The topic. So this is echoing the informations inside the topic where it is trying to display the topics in real time. So inside ROS, there's a actual um, method called spin, where every single thing inside ROS is running in a loop. For example, the spin durations is about like several milliseconds. So there will be different message that is displaying through the ROS topic once every several milliseconds, I guess. So yeah, when I control the total, you can see the changing informations inside that topic of the joint states. So yeah, so that's basically it. So now we are going to the publisher theory, where we have, for example, we have a node. The nodes will serve as a publisher and publish message to a topic. And then there is another nodes, or it can be the same nodes that subscribe to that topic, and then do several actions between it. And then based on the topics that's based on the information inside that topic, and it can do several different things that based on the code of the users. So let me actually demo how to actually write a ROS topic or ROS publisher. So in here we have a minimal publisher in here. We are publishing a string message, std message, dot message. So first of all, we have to create a publisher. We have the minimum publisher class, which extends a node. This node is the actual nodes that we have shown on the slides. And then inside this node, there's publisher, right? Create publishers. First of all, we have to define what type of message that we are trying to publish, and then what topic we are publishing to. And then this is the, I don't actually remember, let's see. QoS profile. I would guess this is some configurations regarding spin time of the ROS, but it's actually saying how much we are limiting ourselves of publishing below or above 10 milliseconds. Oh, RCLPy is going together with the ROS2 libraries or ROS2 framework. So when you successfully install the ROS2, you can also import RCLPy. Yeah. Right. So RCLPy is basically the bridge between ROS2 and Python. And it's basically provides different interface that we can implement. We can control ROS2 easily using Python. So in here we implement the nodes class, right? And then basically these publishers we create first of all create timer, and then we set the timer callback. So basically for every single 0.5 seconds we publish a message. In order to publish a message, you create a new message using a message class that we have imported, and then message.data, set the message.data, right? And then we call publisher.publish, and then that's it. And then now for every 0.5 seconds, it will publish to the actual topic. So how do we run this? We can just, let me actually close this. Cd ROS2 theory. It's 5. So every single time I had to source a Python environment. So Python, we can just normally call Python as normal. ROS2 theory and 5, and then minimal publisher. So this is logging all these message every 0.5 seconds. So now when we check the topic, we can see that there is also a topic name topic, because we name this topic. We are publishing to this topic. That's a weird name, but yeah, let's do like topic 2 or something. Okay.
So you create a new topic, and then as part of the initialization of the publisher node.
Yep. Yeah, and then I run that scripts, and then it will publish to the actual topic 2 topic. And then when I show the ROS2 topic list, it will show here, right? And then when we echo ROS2 topic echo topic 2, we will actually see the message that is currently inside the topic every 0.5 seconds. So until here, do you have any question?
So which node is going to subscribe to
Um,
this topic?
Yeah, so whichever the nodes that we write, right? So we are going to be writing a subscriber node as well to subscribe to this topic. But when we echo, we can see the topic directly. Yeah. Okay. So let's actually get to the subscriber. So in here, you can see that a publisher can publish message to a particular topic, right? And then it can spread data to any subscribers that subscribe to that topic per se. And the way to write that is very simple. Let's see, minimal subscriber. So the subscriber is a little bit more complex, where you first of all also create a node, and then you have to create a subscriptions inside the node, and then first you specify the type of that topic, and then what topic are you listening to, and then you specify the callback functions that receive that data and then do something. So in here, I subscribe to a topic named topic 2, and then I pass in the listener callback. The callback functions here is basically telling what are we going to do with the data received from the from the topic, right? So for example, if the message here is a string, then right, we can log the string, for example. Message.data is a log, and the count is the number of messages that we have received. So let's actually run this. So in here, we know that we are still publishing every 0.5 seconds. So now we actually run ROS2. No, that's not ROS2. That's source. Oh, and then Python ROS theory, and then 7, no, 6. And then now I start a subscriber, and then it will subscribe to the message. The reason why it's not working is because I have not saved. Okay, so here the subscriber subscribed to the topic named topic 2 here, which is also the topic that we are publishing using another threads or another publisher nodes. Right. And then it's showing exactly what the data is inside that topic and is currently being published by the publisher. So yeah, that's basically a publisher subscriber concept. Do you guys have any question?
So whenever I create a new subscriber, I need to follow this
Yeah,
template.
yeah, that's right.
And you need to specify the topics that
Yeah.
you're subscribing to.
Yeah.
Can you subscribe to more than one topic?
Yeah, totally. There is a way to subscribe for a single node to subscribe to a multiple topics. Basically, if you want to do it in parallel, there's a group callback functions that allows parallelism of subscription. If you want to do it in sequential, there's also API for that as well. Okay.
So far so I suppose we see how they can communicate with the publisher and the subscriber, and then the medium for topics.
Yep. So in the actual real world robots control and simulations, the laptop will send a joint state control commands to topic, and then the robots will continuously listen to that topic, and then it will try to move its joints and move the arm based on the informations or commands from that topic. Yeah.
So then you have to define the list of topics.
Yep. In fact, there's a lot of topics need to be used in order to operate a small robot. So for example, there's joint states, there's velocity, there's cameras if one have observations, there's visual informations. There's also different sensors, control different way of controlling, of moving the sensors, for example, controlling the velocity of the wheel, the roll, pitch, yaw, if you're doing drone, right? So there's many different topics to manage.
So technically you can consider all of those parameters as the body of the masses.
Yeah, that can also be done.
With the angle of the joint and then the velocity.
Yeah.
So you define that as masses, the body of the masses.
Yeah.
You can try to say, I split them into different topics.
That's right. Yeah. So for example, in some cases, there is different modalities of data that it might not be available. So that is when the separations of different topics comes in. It simplifies the flows of data. And then if a message has a lot of information inside it, it might cause a little bit of latency inside transformation.
Okay.
Yeah.
Okay.
So any more question?
Câu hỏi gì ta? Tôi cho là nó phải hiểu vào abstract quá không?
Mình nghĩ là tại vì cái này cũng là một term khá là mới, cho nên là có thể là các bạn sẽ cũng cần khoảng thời gian để process được các thông tin. Ví dụ như là em thấy em hiểu là cái nó sẽ chạy là một computer pressure, ở đây nó sẽ có các cái lệnh để gửi đến thông qua cái topic và gửi đến các cái action ở subscriber. Thì cái này để em hứa anh có thể thử chạy một cái case nào mà chạy song song nhiều subscriber.
song song nhiều subscriber.
Thì tại vì anh như anh nói là cái này có nhiều người có bao nhiêu subscriber cũng được, và mình sẽ cái hay là nó sẽ chạy song song với nhau. Thì em không biết là nếu mà mình chạy song song quá nhiều subscriber thì nó có dẫn đến ảnh hưởng về cái độ trễ của máy.
Cái đấy tùy thuộc vào
Vâng.
cấu hình của máy.
Ừ.
Và cái ROS này, kiểu ROS và ROS 2 nó được thiết kế là để làm tất cả mọi thứ đấy in parallel, song song. Thế nên là anh thấy là mình cũng thử làm cái test case đi.
Vâng.
Đây, mình sẽ tạo một cái node mới, xong mình chạy nguyên lại cái script đó. Let's do mình sẽ chạy lại một cái subscriber mới, và những cái subscriber này vẫn đang chạy nhé, đây vẫn đang chạy này.
Vâng.
Đây, vẫn đang lock đấy. Thì đây là một cái node khác chạy song song. Thì đây là một cái subscriber thứ hai, subscribe to that topic. Đấy, thì ví dụ như là mình có một cái applications là, ví dụ mình có một cái đội drone chẳng hạn, có 1.000 con drone, thì mình chỉ cần điều khiển, ví dụ như là điều khiển cái con drone đấy bay cùng một vị trí và offset nó đi. Đó thì khi mà mình publish, mình chỉ cần một cái publisher thôi, publish vào trong một cái topic thôi, thì 1.000 con drone đấy nó sẽ nghe cái topic này và nó sẽ offset đi. Đó thì nó sẽ tạo ra một cái đoàn drone nó bay nó đúng vị trí chẳng hạn. Thì không cần thiết là phải ờ, tạo 1.000 con publisher để gửi cho đến từng con role một. Thì như thế nó sẽ tiết kiệm được cái đường truyền, thì như vậy.
Thì em không biết là cái này nó có liên quan đến cái bài toán của xe tự lái.
Ừ.
Em có một số các case, một số các project về xe tự lái cũng sử dụng cái ROS 3 này, ROS 3.
Có đấy. Thường là những cái ứng dụng về robots thì người ta sẽ dùng rất nhiều ROS. Ờ, Thêm một cái nữa là, nếu mà kiểu muốn low level hơn ấy, thì có thể là người ta sẽ không dùng ROS, người ta sẽ dùng thẳng kiểu cái code kiểu gần như là mã máy, kiểu assembly các thứ nhiều hơn, nhưng mà cái này vẫn là phổ biến nhất. Ừ.
Thế mình trong thiết kế giống như kiểu là nó sẽ support các cái hệ multi agents, tức là nhiều nhiều các cái agent khác nhau.
Vâng.
Bởi vì nó ở đây nó giống như kiểu nó đang define ra một cái communication protocols
Vâng, đúng rồi ạ.
với các cái agents,
Vâng.
và nó emphasize vào cái maybe the efficiency rồi accuracy đó.
Vâng, đúng rồi.
Trong cái communication. Mà mình đoán là ROS thì nó cũng sẽ define ra những cái tính năng về um, access control chẳng hạn, đúng không? Ví dụ subscriber mình có thể listen to certain message nhưng mà không phải tất cả các message.
Đúng rồi.
Ừ.
Đúng rồi, thì
Thế là nó giống cái information systems.
vâng, vâng, đúng rồi.
Kiểu multi agents systems.
Nó như kiểu một cái framework, kiểu message passing framework, làm nào để giao tiếp giữa robot với cả những cái subscriber với cả publisher.
Ừ. Ừ. Tức là ở đây mình chưa nhìn thấy gì gọi là LLM gì không? Mình đang nhìn thấy là communication systems. Đấy.
Và tiếp đến thì mình sẽ thực ra là sắp xong rồi. Sau khi mà nói qua service với cả launch thì mình sẽ đi vào luôn code, làm nào để code của con robot đấy và điều khiển robot và bằng LLM.
Thế có một cái take home exercise cho mọi người ấy, là một cái homework ấy, là tâm thầy vẫn đang rất là curious về cái cách họ define cái term mà topics, publisher và subscriber này. Đúng không? Tức là the some level là nó một cái abstract definition của tất cả các cái hệ robots mà họ có thể nghĩ đến, đúng không? Tức là trong bất cứ một cái hệ robots system thì nó sẽ có một cái mà người ta có thể gọi là một cái publishers, có một cái mình người ta gọi là subscriber, có những cái gọi là public message. Đây còn một cái nữa là service này.
Service đúng
mình
không?
chưa nói đấy.
Vâng, đây bây giờ em nói.
Thì tức là giống như một cái abstract như này, một người học programming đúng không?
Vâng.
Tức là cái abstract class ấy, thì nó có thể được extend thành rất nhiều những cái more concrete, more specific instance của cái abstract đấy. Thì ở đây giống như là việc họ nhìn thấy là tất cả những cái robotic systems programming thì nó sẽ có thể được mô tả bằng một cái hệ thống abstract như này.
Vâng.
Thì tất cả take home exercise là mọi người tìm hiểu là tại sao thì có những cái thiết kế như này. Khá là thú vị.
Okay. So I guess I'm gonna now talking about service. Yeah, so service is a little bit different from topics. Basically, if topics is a little bit like straightforward and direct, then a service is a client's form. It forms a communication pair used for request and response interactions. It's more like a when you code a web, right? You send a request to a server, and then it's just responds using they respond different data types, for example, JSON or something like that. So for comparisons, topics is one way and continuous and many to many, and it's good for sensor data, transportation, communications. The service is, on the other hand, is two-way. It's one-to-one, right? And it's synchronous. It is not asynchronous. It is has to be done in sequence. Yeah, in sequence. So it's good for like abstract comments, like move arm to this positions or like move arm to the home position, for example, or get status of the robots, for example. So the key components of the service is basically there is a service, right? A nodes can have like multiple service, can serve as a service server that's provides the logics for the response. And then there is also a service clients where it sends a request to a service, and then it waits for the response. For example, if we are coding up a robotic nodes, that's robotic nodes that's trying to enable the robots. For example, you have to send a service request to the robots service server to enable the joint states or the joints of the robots, and then it was sent back the response whether the robots has been successfully enabled the joints.
Let's have the topic of service.
Dạ.
Sự khác biệt giữa topic và service.
Vâng, sự khác biệt giữa topic với service thì anh có thể thấy là topic thì nó là một cái trung gian như kiểu one to many, nó là kiểu one to many relationship between the publisher and the subscriber. Nhưng mà nó là one way ấy, tức là publisher publish to topic and then topic đến subscriber.
Broadcasting.
Đúng rồi, broadcasting.
Broadcasting.
Còn service, cái mô hình của nó thì nó là two way. Vâng, one to one và nó là two way. Thì mình gửi cái request đến server và server sẽ response. Cái này thì thường là nó sẽ có tác dụng ở trong những cái trường hợp như là khi mà mình muốn con robot làm một cái hành động gì đó cụ thể và sequential, tức là cái service paradigm này nó tất cả đều phải được làm in sequential, synchronous. Đó như kiểu mình gửi một cái request đến server xong rồi mình nhận về response ở trong web, trong web programming. Thì ví dụ như là có những cái ví dụ cụ thể như là mình enabled the joint state commands or joint state control of the robots, thì cái đấy là service, bởi vì mình phải ra lệnh cho con robot là enable cái đó.
Mình phải acknowledge là nó đã được enable.
Đúng không? Đấy, mình phải acknowledge
cái đấy thì nó không phải là broadcasting kiểu
vâng. Oh yeah, let me actually demonstrate the service as well. So wait. So the service implementation is a little bit very simple, very similar to a subscriber and publisher. You also have a class that extends a node, and then you have self.create service, and then you actually pass in the class. Let's see. Okay, so there's example interface and add to integer. So there's add to integer here. It's basically lower level class, but basically you can try and say you add two integer together. And then finally, right, if you want to create a service, finally you pass in the service name, right, and then pass in the callback for the service. And then here's the actual function callback. There's different ways, where there's different command type in here. I'm just gonna run the code as well. So when I run this node, it will actually publish it's actually create a service called execute commands. And then whenever there's a client that's use this service or send a request to this service, it will process the logic inside the execute commands callback. So that is the service, and down here is the command client, where it's actually sending the request to the server. We send the command to the add to integers request to the service, and then it will have a callback, and then command respond callbacks. Whenever it receives a response from the future, it will try to lock the thing. So let's actually run this just to see what it is. So let's actually stop this. Python, and then ROS2, then 7, and then command service. Wait.
The robot command service.
That's weird. It's here. Robot command service stop py. Python ROS2. Oh yeah, it's gonna be. Yeah, I'm running the service first of all, and now I am trying to run another node, which is the client node. I'm just gonna do this. So let's say I run the clients here. Yeah. So whenever the client sends a request to the server, it will be the server will process the request in here. For example, stopping the robots, received command rotating the robots, and moving robots, something like that. And then the robots, and then the clients, the service clients will receive that results, whether the server has done the job, something like that. So the reason why I mentioned this service and service client in here is because we are going to be using it to enable the robots when we are in the actual practical applications in simulations of the PX100 robot arm. So yeah, so do you guys have any question? Okay. This is a nice add-on to the ROS2. So there's one thing called URDF, which is Unified Robots description format, where you can actually code up every single descriptions or physical things, physicals like structure of the robots, for example, to visualize it on gazebo and then our RVIS program, stuff like that. So basically, URDF is an XML format used to describe robot physical structure, including like links, joints, sensors, and visuals, and inertia, collision, and so on. And then there's launch files, which automates the process of starting multiple ROS nodes and setting parameters. So in ROS2, people write the launch file in Python, not XML like in ROS1. And then we use the launch and launch ROS or ROS launch libraries to run the actual launch file. Typical use case includes like starting a robot's descriptions and state publisher, and then launching sensors, launching controllers, navigation stack all at once. And also we set the parameters and remote topics as well. So here is a an example of the URDF and launch file. So simple robots.urdf. It is in the form of XML, and in here I specified base link. There's link, visual, and geometry. There's been specified all the boxes in 3D coordinates, and materials as well, color. Here is also specified the arm and the end effector. And then there's joints, like which joints do we have, and then what kind of joint states or topics that is listening to in order to control the robot's joints. Yeah. And then here is the display robot.launch file, where we launch the actual simple robots URDF onto the visualization program, which we will use in the PX100 demo. Right? Basically, the launch includes the launch configurations, and then when you have the configs, you initialize the nodes, all these nodes, publisher and subscriber, all at once, and then also you have to the visualization platform called RVIS is also another node where it is listening to everything. And then finally, you have return the launch descriptions. Finally, run it by the ROS launch. In here I call exec ROS2 launch this display robots.launch.py. So yeah, so let's actually run this in order to see what is being displayed on the visualization platform RVIS. Okay. I guess bash ROS2 and then launch.sh. ROS2 launch. Let's see what is that? Yeah, I think I need to get into the actual folder. So if you can see the actual RVIS program, that's gonna be in here. So here is the actual robots that is coded up using the URDF file. It has the one block and then like different joins in here. And then it has a joint state publisher where you can publish the the control of the arm or control of the joints, right? So in here you can see, for example, I can drag base to arm. You can like go around, and then arm to end effector. You can control the an effector of the robots that we have shown in here in the URDF model of the robots. So underneath this joint state publisher is also a node, right? As we have talked about as a publisher node, where it published to a topic. And then this RVis or launch will launch another node called subscriber. And then that subscriber will subscribe to that topic that's listen to the joint state commands. And then that's will control the URDF inside this. And then the RVis nodes will listen to everything to the robot's joint states, and then it displays onto this screen right here, visualization. So that's basically everything for the ROS2 theory. Do you have any question?
So you have publisher node and subscriber node, and then you have visualization node.
Yeah, yeah.
So the service here is, what is the service?
So in this example, I did not use service, but I will demonstrate the service usage inside PX100 robot arm. Yeah. Okay. Let's close this.
Cool.
Okay. Okay, let's close everything. Close turtle, close. So next we are going to demonstrate the robots. So here is a general paradigm or structure of nodes. In here we have PX100. Whenever we run the nodes PX100, there's this amount of nodes, like different topics, this amount of different topics. That's the PX100 is either listening to or publishing to. So there's a lot of them, but we just need to care about three main topics. First of all is PX100 joint states, which is displaying all these joint states informations of the robot arm. And next one is arm controller joint trajectory, where we will have a separate nodes that sends or publish the commands into that arm controller or a joint trajectory. And then it will control the robots, right? And then also gripper controller. This is also another controlling message topic where it's control the gripper of the robots. So the PX100 has 5 joints or 4 joints in the gripper. First of all is, okay, let me actually open the visualization first. So here is all the setup scripts. I will send you all the GitHub links, so don't worry. Setup scripts for the robots. And then after all the setup, finally I run the PX100 simulations.sh. So in here, you can see that I use ROS2 Launch and then the actual launch file inside the robots, and then specify the robot model, and then specifies the visualization platform. You can also take a look at the launch file on the Interbotix documentations and also Interbotix GitHub. I will also put the links here in the slide as well. So let's actually run this. Okay. Oh, I have to do this every time. Okay. So source ROS, and then finally bash px100. Let's do run px100 sim.sh. Okay. Gonna be a little bit here. So here is the PX100 robots. you can see that it has first of all this wrist joint. This is shoulder, and this is the wrist angle, and then this is the gripper. And then the goal of this is to control each joint by sending the publisher commands to the to each joint of the robot, right? So let's actually go through. Let's actually check out the topic, shall we? So first of all, let's see, what topics do we have? So in here, ROS2 topic list. So when we run this, when we launch this robots PX100 nodes, right? We have PX100 arm controller states. We have joint trajectory. We have states. We have transition events. We also have different gripper controller joint trajectory, and then controller states, and then states and transition events. We have the PX100 joint states, which is the actual current joint states of the robots. This is the publisher notes from the robots. So that means the robots is publishing to this topic, and then we are listening to topics to get the current joint states of the robots. And then this channels, all these topics like arm controller states, and joint trajectory. This is the subscriber nodes inside the robot's arm, where the robot's arm is listening to this topic for getting the comments from the human or from the keyboards, for example, in order to move the joints, right, by some amount of radians or angles. Other topics you care about, but basically it's basically it. So let's actually code up the publisher and subscriber for this nodes. So in here I have the sim pops up, or simulations publisher and subscriber. So there's different things here. There's two things. This is one example of incorporating multiple publishers and multiple subscriber inside a node, and then call it in parallel. So in here we have, let me actually collapse all this for simplicity. Okay, so inside the init functions, we have different joints, waist, shoulder, elbow, and wrist angle. And then finally the gripper, which is in the different channels. Then I have the joint limits. I just do that for safety of the actual robots. We do not have the actual robots here. We only have simulations. I put my my robot's arm in the United States. But if we have like the actual robots, it's gonna be very interesting.
Yeah, a robot in HD.
Oh yeah, that's very cool. So this incorporates a little bit of parallelism and different threads for processing, including threading, not lock. And then we have a different subscriber publishers here. So first of all, I want to create. So the goal of this is to control the robot's arm using a keyboard. So I design a interface or pygame interface that allows the user to control the robot using keyboard, right? So whenever we want to control the robots, whenever we press the key, right, we are generating a command or joint states commands, and we send it to the commands arm control topic of the robots, right? And then the robots will listen to that commands and moving the joints, right? So that is the publisher here. Where we have the arm control, we publish to PX100 arm controller and joint trajectory, and also gripper controller joint trajectory. And then finally, we create a subscriber that is listening to the joint states of the robots. So remember here, we're passing the join state callback, and then join states callback, we are just setting all these current data that is currently inside the join state topics to the join state, but everything is done in parallel. So we need to have a lock. That's basically it. Because we don't want this, we want this to be atomic as well. So now the pygame interface. Well, all of this other methods will be called when the user press the keyboard, right? And then that is when we we use the publisher nodes to publish the information to that channel. So let's actually go into the pygame interface first. In here, I assume that you all know how to create a pygame, backgrounds and phones and stuff like that. You can just take a look at the code, but basically, the main key idea of this is to implement the control, right? So the control will be changing the controlling each joint, and then we changing the joints to different modes, right? And then we press up and down button to move the joints away, or left or right, something like that. So whenever we are pressing the button, for example, we call the ROS nodes that is previously initialized, and then we press move gripper. So move gripper is gonna be in here. It's gonna be inside the ROS nodes, right? And then whenever we move the grippers, we are setting the trajectories, and then we publish these trajectories. And then the publish will also be inside the node class of the publishers. Right. So yeah, so let's actually run this to see what it is. So time. Okay. So we can see in here, wait. Let me close this and then move this down here. Move this here, here. Yeah. So in here is a simple, a very brief and simple way to control the PX100 arm. There's different joints, right? There's waist, shoulder, elbow, and wrist, and then there's the gripper as well. So 5 parameters to be controlling. So every single information here is displayed by subscribing to the joint states topic of the robots. All right, and then whenever we press up and down, we are sending the trajectories data to the topic, to the arm controlling topic of that joint to the robots, and then the robot will be moving, right? So I'm pressing up arrow button, and then it will adding the trajectories joints commands, or delta. Delta is a little bit small, about like 0.2, I guess, 0.15. And then now I am pressing the down button. It will controlling the robots, reducing the amount of angle of the robots. And then it's trying to move the waist of the robots. So now I press the right arrow buttons. I can control the shoulder here. Another right, I can control the elbow. Another right is controlling the wrist. And then space is to open and close the gripper in here. So I'm pressing space. Yeah, so that's basically the idea of controlling the robots through the publisher and subscriber topic. So where do we use service in here? We use service to actually enable the the robots control. There's no surfacing.
Is it in
It has to be somewhere in both files. Let's see, maybe that doesn't need a service, but I actually remember it actually uses service as well. Yeah, it doesn't. But it's good to know.
That's because you only have one.
Yeah. That might be, yeah. Sometimes when you want to enable or when you want to enable the control type or control mode of the robots, for example, you have to use the service of the robots. So for example, controlling by velocity or controlling by 3D coordinates, Cartesian coordinates, for example. If you want to specify control the robot by specifying the 3D coordinates in the 3D world, you have to change the mode to that. And then the reason why we're changing the modes. And then the way we do it is we using the service, right? That is also one application of this using the service.
I have a question. Can it be running autonomously? Because so far I saw that you're controlling. So I'm wondering that if we might, having a system to make it autonomous so that like the factory we can use it.
Yeah, that is a very brilliant question. The answer is yes.
Yeah.
We can totally use it. And this is the whole point of controlling autonomously, right? Where we can control the robots by automatically publishing to the robots. In fact, the research project that I'm doing is basically having the robots interacting with the world and then subscribing and then continuously publishing the information from the world to the laptop. And then the laptop will actually serving as a brain and then producing a sequence of actions or planned actions for the robots, right? You can plan the actions using different methods, for example, different planning reinforcement learning methods, for example, or you can use LLM, or you can use like any other methods, but to autonomously planning the robot's action sequence. And then you can just publish the robot's action sequence back to the topic that control the robots, and then the robot will autonomously moving by the brain or the laptop. Yeah.
I got the idea.
So yeah, any question?
Also, could you tell us more about the project you're currently doing? Yeah, the LLM and robots behavior.
Is there another demo?
Yeah, I do.
Maybe you could like display us a demo of so far the progress of the project.
Okay, so this is only the tutorial, but regarding the progress, we are working on a LLM controlled. So we're using the large language model to control the robot's arm to actually pick and place the block, and it's based on the robots actually takes in the observations, the visual observations, and then the joint states as well, in order to understand the surroundings and the context and every single observations from the environments, right? And then takes in all of those observations informations. Then we trying to fit it in multimodal deep learning or multimodal deep large language model, right? And then the large language model will produce a sequence of actions that have the robot's plans, and then it's actually learns to successfully do the tasks by learning from reinforcement learning, for example. Can be Bellman equations, can be using deep Q network or something like that.
Interesting.
Yeah. Yeah.
So the LLM is for like managing tasks.
Yeah. So when you try to say, hey robots, pick the red block and place it on top of the green block, for example. it is also one modality of observation to the robots. So it will be serving us instructions from the human, or the goal set by human, right? So for example, if you go into the factories and try to say pick any kind of blocks or pick any kind of rubbish or something like that, like filter out any rubbish from the streams of things, for example, right? It would actually do according to what you say. Or another applications can be the robot assistants, right? Hey robots, fry me an egg, for example, or make me a coffee. You actually try to do it, I guess. This is more like we are trying to heading toward like a generalist robotics, right? Where the robots has the ability to reason with language, right? Based on the human's instructions and goals. Yeah, so that's basically it.
It's really interesting. I have just one more question is that the use case of the projects it's like for factory or like for robots helping with housework.
Yeah, it can be anything. I think it can be anything. Basically, any applications that involve human talking to a robot and commanding a robot what to do using natural language, and then any kind of applications that does not require hand coding, like hand coded or hard coded algorithms for robots. We can just command them by just talking to them.
Em có một cái em suy nghĩ nãy giờ em chưa clarify được là em vẫn chưa phân biệt được cái topic với service ấy. Ví dụ như là em đang hiểu là cái topic đi thì nó sẽ là one way đúng không, là ví dụ như là những cái mà mình cái topic sẽ ví dụ như là cái vị trí của con robot này, cái góc nó đang ở bao nhiêu, nói chung là cái status của con robot. Còn cái service nó sẽ là những cái mà mình request nó, ví dụ là cái di chuyển bao nhiêu đấy hoặc là dơ bao nhiêu đấy, có đúng không?
Đúng không?
Nhưng mà thế thì khi mà em hiểu là khi mà cái AI tích hợp vào thì nó sẽ ở cái bước nào và nó sẽ hoạt động như nào?
Thực ra là khi mà mình cũng tức là khi mà mình muốn control một con robot thì mình có thể publish cái comments vào cái topic để con robot này nó nhận và nó sẽ cử động từng cái join một. Em có thể làm như thế. Em cũng có thể tạo một cái service riêng luôn, là ờ, service là kiểu mình sẽ request con robot là làm một cái hành động nào đó, thì nó sẽ là một cái kiểu high level hơn ấy. Và khi mà con robot này nó nhận được cái service đấy thì nó cũng sẽ kiểu cử động một cái joint nào đấy thôi, thì nó cũng khá là giống nhau, nhưng mà về cái context, về cơ bản về cái context đấy nó lại khác nhau một chút. Là khi mà mình làm trong service thì mình gửi cái request đến cái server, và server nó sẽ trả lại response. Có thể là ví dụ như là những cái ứng dụng mà có thể là em enable một cái gì đấy của con robot chẳng hạn, hoặc là em disable một cái gì đấy của con robot chẳng hạn, thì em sẽ dùng service. Em kiểu bắt nó làm một cái gì đó, ờ bắt nó thực hiện một cái thao tác kiểu logic nào đó. Còn về cái phần topics thì nó sẽ thiên về message passing nhiều hơn, là kiểu kiểu bắt nó làm cái gì đấy. Does that answer your question?
Ví dụ như là khi mà mình tích hợp LLM vào thì có nghĩa là nó sẽ, mình có một câu input đi thì nó sẽ xử lý ra, của LLM nó sẽ xử lý là mình sẽ cần có những cái service nào và cần có những cái topic nào để truyền cho con robot này.
cũng không cũng không hẳn. LLM ở trong này thì thực ra là khi mà mình có một cái prompt, đúng không, mình muốn gửi đến con robot chẳng hạn, thì mình sẽ đưa cái prompt đấy gửi đến một cái topic nào đó để con robot nó lắng nghe cái prompt đấy từ một cái topic nào đấy. Sau đấy thì nó sẽ take in cái prompt đấy và nó sẽ xử lý cái prompt đấy trên cái bộ não của nó chẳng hạn.
À, ừ.
ví dụ đơn giản là em pick up một cái quả táo trong cái tủ lạnh này, đúng không? Thì em phải làm các cái step, đúng không? Đúng là phải di chuyển về cái tủ lạnh này. Open the door này. Get the apple này. Em đóng cái cửa tủ lạnh này, đúng không? Thì cái prompt, initial prompt của mình nó không bao gồm tất cả những cái step thế, nhưng mà giống như kiểu em given một cái instruction như thế thì em sẽ phải còn có cái step. Và tức là em phải có một cái, em phải come up với một cái plan, đúng không? Nó tức là một planning ý. Planning trước, xong thì mình bắt đầu execute những cái step trong cái plan đấy. Thì chắc là cái phần LLM là nó phải requires là em phải be able to derive the plan given một cái instruction.
Vâng.
Đó.
Trước em còn thấy một cái video của OpenAI, cái video ấy khá lâu rồi, là họ có display cái con robot ấy. Con robot nó vừa làm các cái hoạt động dựa trên ra lệnh của con người. Thì em đang thấy nó khá là giống với cả cái đang nói ở đây.
Đúng rồi.
Cái LLM tức là con người tư vấn lệnh, và sau đấy nó sẽ tự quét công việc để nó thực hiện theo trình tự.
Và chính xác là cái ứng dụng đấy luôn.
Vâng, em nghe em khá là giống.
Thì về project, cái này là kiểu tutorial là làm thế nào để có thể làm được như thế. Đây là những cái bước đầu. Còn những cái bước tiếp theo thì mình sẽ làm nào để integrate cái con like fully autonomous và dùng LLM để đưa ra những cái actions planning cho robots.
Tôi có thể show cho bạn cái phần LLM này xem là cái
Okay.
cấu phần đấy LLM em sẽ đưa vào.
Cái phần LLM ở trong tutorial này thì em hướng đến là mình sẽ điều khiển con robot bằng lệnh của con người. Ví dụ như là move up, move down, right or left. Đấy, thì đây em sẽ chạy. Tức là nó cũng giống y như là cái script cũ thôi. Nhưng mà mình sẽ thay cái join state control by keyboard bằng LLM. Và LLM này thì mình sẽ làm nó vì để simplicity, for simplicity reason thì I wanna send the prompts to ChatGPT and then get the answer back, and then the answer will contains all the joint informations. So there's predefined prompts in here. So system prompts basically you are a robot control assistant, right? It translates natural language. And then I specified all the limits of the width, shoulder, elbow, and wrist angle, and gripper. And then specified the structure of answer from ChatGPT. And then we will actually port the reasoning process to the ChatGPT. And then it will return the prompts or return the answer as actions, and then we just parse it and then get it to the robots. So that's basically the idea. Let's run it. So in here we have the robots, and then we also have the control. So in here underneath this, we enter the command, right? So for example, move left. What it is doing is basically it sends the prompts to the ChatGPT, and then it will reasons which joints to actually moving, right? And then send back the answer. And then we successfully parse the join state commands, and then we just send the parse join state commands to the robot's arm controller on topic. For example, in here we can like move down. It will control the waist. Right? Move left and move down, right? And then go to home position, for example. It will go back to the home position right here. And then what else? Move up like 4 times, for example. It will move up by some amounts of radians, right? Move left more than 0.4, something like that. And then it will move by some amount of radians as well. So yeah, so that's basically how I integrate LLM into the controlling of the robots. So from here, you have so much potential to actually work on these robots or any kind of robots that use ROS as a like protocol for communications between the brain or the laptop or any kind of compute and the robots, right? And then you can have the laptop or the compute planning all these action sequence for the robots and then send this to the robots for the actions of the robots and the interactions between the robots and the environment, which is very cool, I guess.
Do you have the humanoid?
Oh yeah, I do.
Humanoid.
Yeah, I do have humanoid. It's not in here, by the way. I also plan doing in my research all these humanoid robots and very like cool things.
Yeah, the reason I'm asking is tức là VinMotion thì sẽ có một cái lab rồi VinUni sẽ tập trung vào humanoid, cho nên là hiện tại thì bây giờ họ đang làm cái phần motion, cái phần cấp cứu một chút.
Yeah.
Và câu chuyện của 1-2 năm tới sẽ là perception training cái kiểu thì tức là cái robot arms này thì nó là một cái đối tượng đúng không? Một cái loại robot
Đúng không?
nếu mà mình muốn làm cái dự án về VinMotion thì sẽ phải là về với humanoid.
Yeah, humanoid thì nó cũng có rất nhiều những cái URDF ở trên mạng, ví dụ như là DM control là nó cũng có làm về humanoid kiểu như là humanoid walking hay là standing hay là running kiểu đó. Thì nếu mình có một cái actual humanoid robots, mình có thể communicate with the humanoid robots through ROS2 and then finally planning on some compute can be like edge computing device, can be GPU, it can be like anything, laptops or GPUs A100, something like that, and then publish the planning actions through the ROS2 and then onto the human robots and to control it. And then this proved the potential to control the robots autonomously, like any kind of robots.
Thực ra là họ có cái hardware rồi,
Dạ vâng.
nhưng mà họ sẽ muốn collab với VinUni để làm những cái research. Thế nên là mình có thể train ourselves để mình làm những cái dự án như vậy, tức là cần testing thì có thể dùng cái resource của bên họ. Nhưng bên mình thì sẽ tập trung vào cái phần software hơn, nó còn mình test về simulation rồi sau đó là test về actual humanoid. Thì lấy cái idea, nhưng mà mình cần phải có cái capacity trước bạn. Mình có những bạn biết làm việc với ROS chẳng hạn, rồi hiểu về cái cách lập trình robot, đặc biệt là integrating những cái tools như là LLMs. Cái bản chất thời gian nếu mà mọi người nhìn thì nó thông qua tất cả những cái abstract module mà mình thấy publisher rồi subscriber rồi topics service. Cái đó nó là cái language rồi. Cái core chính là cái bài toán mình hay làm reasoning và planning từ cả theo cái form chẳng hạn. Đó là cái bài toán mình tập trung vào. Mình chỉ cần học cái tool thôi, học được cái tool xong thì đến lúc quen rồi thì cái pro như anh Dũng chẳng hạn thì nó tập trung vào cái phần này thôi.
Tại cái mảng này mình cũng bảo tiếng ngách khá ít bạn biết được như này.
Các thực ra là tại vì mọi người chưa quen dùng cái
chưa quen
rồi
này
cái library, cái framework thôi.
Framework chưa quen.
Còn quen rồi thì nó không cái công cụ.
Okay.
Yeah. That's the end of the presentation as well. So
Thank you, anh Dũng.